Hello. Hello everyone. Good evening. So, welcome to the week 6 of the tutorial session of the course Introduction to Robotics. Today we are going to solve some of the question based on the week 5th and week 6th lectures which has been taught in the NPTEL portal. So this video will be also recorded and uploaded on YouTube. So the students who are not able to watch it now can watch on YouTube. And also the link for the YouTube will be provided in the NPTEL section. So we'll start the tutorial session. So we'll start with our first question. So this is a theoretical question. So we'll also solve some of the numerical question as well. So in this question, it is asking pick out the correct ones from the following statements about actuating systems.
Hello.
Yeah, others say.
Uh, Sir, a small request. I was solving the assignment 6, and I find, I may be wrong, I find question number 9 had some missing data. It seems so.
I think this kind of question you should ask on the forum because the question they only make. Let me check what is the question number 9. I'm not seeing the.
Sir, there's some missing data to the average point is. Either you need to know about omega or you need to find out what.
Yeah, so I have not seen the question. Let me see. Because
Okay.
I have seen the previous year assignment question, not this year.
No, this is question number 9,
Okay, okay. Let me check.
assignment 6.
Yeah. So such kind of doubts you can ask on forum also, but okay, let me see once.
Okay.
So what is your doubt in this?
Uh, in order to find out the average voltage in question number 9
Okay.
of the of the assignment 6, uh, input voltage is given, your load is given, but there is no resistance is given. First thing. Second thing, there is no omega is given to find out the back EMF. So how to find out the average voltage here? Without average voltage, I don't think it's possible to find out the duty cycle, duty ratio.
Yeah, yeah, you are correct.
K is given, your input voltage that is given, your load torque is given. But how you will find you can find the armature current. I IA you can find, but how can you find the omega or RA? To find out back EMF or so that we can calculate the average voltage. Then only we can find out the duty ratio. I think is the I may be wrong in this. That's why I asked. Means I'm not asking for any solution. I'm just asking for any hint so that I can solve it.
Okay. Input voltage is given and then question 7. Yeah,
Load torque is given.
yeah, torque is also given.
Okay, it's given.
K is given. Yeah,
From
for
load torque and Q can find out the IA, measure current. But again, About the average voltage. Average voltage is EV plus IA.
Yeah, yeah.
I can't find, there is no RA is given.
Yeah, RA is not given in this.
Let's say I neglect RA. In some cases, we can neglect the armature resistance, but again there is no omega is given.
Yeah,
Then how can I
you need
find out E?
omega to find EB also. So maybe this question is incomplete. Like insufficient data is there. Because for EB also you need omega, and for
That is related to it.
switching frequency is given and the mature inductance is given LA. Remind the peak to peak ripple in the, yeah, this question is also dependent on this. In this it is given we have to find peak to peak ripple. So for peak to peak ripple, VG minus VA.
We need to find out the duty cycle.
Duty cycle you have to find.
Uh, it's a kind of a linked question. Earlier, this question used to come
Yeah, yeah.
for 2014 or 15. But how can you solve it, sir?
And then the data is like not given. So you can ask in the forum. So the TA who make these questions, they can reply.
Which forum, sir?
Like in the course only, I guess the progress.
No, why we are going through going through the lecture, there is
Ask a question option is there, na? Ask a question on the.
here it is not saying, it is only saying send your figure.
No, when you just go to the group, like go to the course,
Yes.
and like in the top there is announcements about the course. Ask a question option is there.
Okay, let me check.
So there you can ask, like you can add new conversation and you can ask this.
Actually, since I am a PhD student, actually.
Okay.
Okay. So this I need to maintain these means these assignments are important in order to secure scores as well as the certification exams also. So I couldn't find anything here
You can add there in ask questions.
because I think tomorrow is the deadline to submit this. But I couldn't actually, sir, I couldn't find any group here. There is a survey is there
No,
even
you
in
can go ask your question option is there in that. Go to your course and then.
this I have gone to the course.
So at the top you will get announcements about the course, ask a question, progress, mentor.
Okay, okay, okay.
Yeah, yeah.
Okay. Join the group. Okay. Understand. Okay, here I can ask. Yeah.
Yes, yes.
Again, new conversation. In this new conversation, I need to ask the question.
Yeah, yeah.
Okay, okay. Thank you, sir.
Because the TA who makes these questions, they will reply and they should give the data like properly. They must have missed it.
Sir, I just in this topic, okay. But what should I get data income?
You can ask what is the value not given. So you can ask in the question number. You mention the question number and assignment number and then ask.
For this.
And we will solve some of the question like
Yes,
based
yes, yes.
on this.
Sorry, sorry.
So, but in this question, all the data are given. Like RA is given and also.
The practice question, the question given in the practice question, all the data are given.
Yeah, yeah.
But there should be some value of omega of RA. Without it, I don't know how. Because we just can't from the input voltage. I mean, if you allow me, then I can. We can discuss for 2 minutes this question. If we will get any output from that, if you allow me. Hello.
Yeah, yeah.
Okay. Because from since K value here is voltage divided by radian per second. If we divide it with our input voltage, we may get value in we will get a value in radian per second. And again, we have to multiply with K. But this is I don't think this is the correct process. For the sake of bringing an answer, I can do that.
Yeah, like unit will be the same, but it's not the way.
Okay, sir.
If
Continue.
input voltage is given 24 volt, then K is given
If I divide
EB
input
by,
voltage by K, then the value I get, it will be in radian per second.
yeah, yeah.
Basically, I get a value for omega. And again, I will multiply with K value, then I get some value about voltage, average voltage. But I don't think this is the correct approach.
Now you can ask there in the forum.
Okay, sir.
So we'll solve some of the theoretical question and as well as numerical question in today's lecture. So the first question is like pick out the correct ones from the following statements made about actuating systems. So pneumatic, hydraulic, and electric systems are given. So the first option is hydraulic actuators are smallest in size for a given power rating. Uh, yes, this is correct option. And the size of the actuators are nearly the same for given power rating. This is wrong. So it depends on types of actuators as well. And electric actuators are easier to control as compared to other variants. Yes, it is very easy to control because you have to just give the input voltage and output some mechanical rotation or anything you can get. And hydraulic actuators are maintenance free. No, it's wrong. So the maintenance are required. So option A and C is the correct for this first question. We'll move on to the second question. So this is asking the torque, impact of torque ripple on an actuating system. So the first option is given. It is lesser if its amplitude is more. Like we have seen in the lecture, there are two kinds of curve. What is discussed. So if the frequency is more, the ripple will be the impact of the torque ripple will be less, and also when the amplitude is more, like if the amplitude of the ripple is more, then the impact will be higher. So for this you can see, so the impact is lesser when the amplitude is low. In this case, amplitude is low and frequency is more. In this case, amplitude is high and frequency is low. In this case, the impact of torque is more higher. In this, it is lesser. So the correct option is the impact of torque is lesser if its amplitude is less and frequency is more. So option B is the correct. So now we'll move on to the third question. So in this question, it is given a long conductor of length 2 meter of resistance having 0.5 ohm is placed in a uniform magnetic field. The magnetic field density is 0.8 Weber per meter square, and the conductor axis makes an angle of 30 degree with the direction of field. Determine the current required to flow through the conductor in order to generate a force of 1 Newton on the conductor. So we all know that the formula is F is equal to I cross dl, so it will be IL sine theta. So here the angle between the axis of current and the length is 30 degree. So here F is equal to, in this question, B is given, that is 0.8. So B is given 0.8 Weber per meter square. I we have to find, and then force is given, that is 1 Newton. And after that, the remaining term is the length. Length is 2 meter and theta is 30 degree. So when you substitute all the value, we will get I is equal to force is 1 divided by 0.8 into 2, and sine 30 degree will be 1 by 2. So it will be 10 by 8, that will be 5 by 4. It will be 1.25 ampere. So the correct option is the option D, that is option B, that is 1.25 ampere. So these are just a formula based question. So we move on to the next question. That is given that a rectangular coil having length of 10 centimeter is given. So length is equal to 10 centimeter, that is 0.1 meter, and the width is equal to 8 centimeter, and number of turns is 40, that is placed in a uniform magnetic field of flux density 1 Tesla. So B is also given as 1. Such that the coil sides are always perpendicular to the direction of field. So it is perpendicular. So the theta will be 90 degrees. So sine theta will be 1. The coil is driven against a constant mechanical opposition of 0.8 Newton meter. So the torque is given as 0.8 Newton meter. Determine the current in ampere following through the coil in this case. Assume that the coil resistance is 0.5 ohm. So we have to find the current. So the formula is E is equal to N BIL, then sine theta, and also the width here, and theta is given as 90 degree. So I is equal to 0.8 divided by N is 40, B is 1, L is 0.1, and width is 0.08. So if we substitute all this value and do the calculation, So answer for this question will be 2.5 ampere. So now for the same question, it is asking determine the speed in radian per second at which the coil would rotate if the voltage supplied by the source to the coil is 10 volt. So we have to find the speed in radian per second. So that is we have to find omega, and also the voltage supply is 10 volt. We know that the formula is V is equal to EB plus IARA, and we have already find the current as 2.5 ampere, and the resistance of the coil is also given, that is 0.5 ohm. So we'll substitute this value so that we'll get EB, because EB is required to find the the formula of EB is equal to 2 into N B into L into W. So this omega, in this we know that we have to find EB first. So EB is equal to 10 minus IA into RA. So IA is 2.5 and RA is given as 0.5. So this will be equal to uh, 1.25. So it will be 8.75 voltage. So now when you substitute all this, we will get omega as 8.75 divided by 2 into 40. N was 40 in the previous in the previous question it was given. V was given as 1. L was given as 0.1. So R will be, the radius will be width by 2, like the total width divided by 2 will be the R. So here the width was given in the previous question as 0.08, so it will be 0.04. So now when we'll substitute all this value, the correct answer will be, it will be 875 divided by 32. So it will be 64, 135. So that will be
273, sir.
something 27 point 235. So it will be around 27 point something. So this answer will be in radian per second. So this is the angular speed, that is the speed in radian per second. So now the next question is, a PMDC motor has an armature resistance of 0.5 ohm, and the scaling factor K between the speed and EMF is 1.9 volt per radian per second. If the motor is energized with a supply voltage of 240 volt while supplying a constant load of 2 Newton meter, determine the speed of rotation of the motor in rotation per minute. So we have to find the speed of the rotation, and that too in rotation per minute. So in this question it is given as RA is given as 0.5. Supply voltage is given as 240 volt and K is given as 1.9 volt per radian per second. So we know that the formula of rotation per minute, that is omega, that is given as V by K minus RA by K square into T. So here in this question, all these parameters are given and torque is also given as 2 Newton meter. So when you substitute all this value, so this will be 240 by 1.9 minus 0.5 ohm divided by 1.9 square into 2. So you can use calculator for this. So the answer will be something around 1203. Like when you solve this, you will get this you will get in radian per second. So after that, you need to multiply with it 60 by 2 pi, so that you will get rotation per minute. Because you need to convert seconds into minutes, so you need to multiply it by 60 and divided by 2 pi, because you need to convert radians into the rotation, because in one rotation it is 2 pi. So for this you will get around something 126. So when you, this is radian per second, 16, it will be around 1200 something. So answer will be 1200 within 2 or 3 rotation per minute. So now we'll move on to the first question. A DC motor has an armature resistance of 0.4 ohm. So armature resistance RA is given as 0.4 ohm. Also the back EMF constant K, that is given as 0.3 volt per radian per second. And the motor is connected to a fan blade whose load characteristics is described by TL, that is equal to 0.002 omega square. So in this question, yeah, omega is given, like where omega is the speed in radian per second if it is intended to operate the fan blades at a speed of 60 radian per second. So here omega is also given, that is 60 radian per second. So we have to find the armature input voltage, that is VA, that needs to be supplied to the motor, and do the calculation correct up to one decimal place. So in this question, for finding like VA, we need to find, so RA is given, we need to find EB. So using this induced back EMF, we can find using this formula. So here with respect, here this V is induced back EMF. So EB will be equal to K into W. So that is K is also given here, that is 0.3, and W is also given, that is 60. So this is 18 volt Now we have to find IA. So IA is equal to TL divided by K. So this is given. TL is 0.002 omega square. So omega is 60 into 60 here. And after that, you can substitute the value of K, that is also given 0.3. So it will be 4 into 6, 24 ampere. So now VA is equal to IARA, that is 24 into 0.4 plus EB, that is 18 volt. So it will be 9.6 plus 18, that is 20. 9.6 plus 18, that will be 27.6 volt. So now the next question, a DC motor has an armature resistance of 0.4 ohm. The back EMF constant K is given, that is 0.3 volt per radian per second. The motor is connected to a fan blade whose load characteristics is described. TL is equal to 0.002 omega square. All these values are same as in the previous question. The armature terminals of the motors are energized from a buck step down DC-DC converter, which in turn is fed from a 48 volt DC source. So if it is intended to operate the fan blades at a speed of 60 radian per second, determine on duration of the switch in microsecond if the switching frequency is chosen to be 8 kilohertz. So here we have to find the on duration. So we know that from the duty cycle formula, that is T on divided by T on plus T off. So T on plus T off will be total time, that is TS, and that can be found using the inverse of the frequency. So here, if the switching frequency is given, that is 8 kilohertz, so here you can keep 8 into 10 to the power of 3. So our TS will be, total duration will be 1 by 8, that is, okay, let it be like this, or 125, 0.125 into 10 to the power of minus 3 seconds, that is equal to 125 microseconds. So we have to find the answer in microseconds. So let's keep everything in microseconds. So we have got this TS. Now we have to find the duty cycle D. So D can be also found using the, in the last question we have calculated armature input voltage, that is VA divided by VG. So in this question VG is given, that is 48 volt DC source. So here we have found VA, that is 27.6. So when we do this calculation, so this will be around 27.6 divided by 48. So it will be 0.57. So now we have to find on duration. So T on is equal to D into TH. So this will be 0.57 into 125 microsecond. So this will be 125 into 0.57. So this will be around 71.8 microsecond. So in this way you can solve this question. So now we will see the next question. In this question, a DC motor has armature resistance of 0.5 ohm and an armature inductance of 1 millihenry is given, and the back EMF constant K of the motor is 0.5 volt per radian per second, and the motor is connected to a fan blade whose load characteristics is described by TL is equal to 0.002 omega square. So we should write all these values, else we will forget what was given. Yes.
Sir, this session is already been carried out on Sunday. So can you continue the quiz session?
Like quiz session have the similar questions, so that's why we have to not to discuss that.
So some this session of which is already have on CC. So it is again repeated. Our quiz which or maybe the next time.
Yeah, next time, okay, I will try. Like initially, they have decided to have the similar PPT for all the TA. So I will tell them.
Okay, sir.
So my session comes at the end, so that's is the disadvantage for me. So next time, I will
Okay,
tell
okay.
everyone to prepare their own slides then.
Thank you.
Okay. So here it is given the armature resistance that is 0.5 ohm, and the inductance is given as 1 millihenry, and the back EMF constant K of the motor is given as 0.5 volt per radian per second, and TL is given as 0.002 omega square. Buckham switching at 5 kilohertz, and TS is given as 5 kilohertz. Sorry, F F is given the switching frequency is given 5 kilohertz. So from here we can find TS. So and also omega is given as 60 radian per second. So after that we have to find determine the peak to peak value of ripple in the armature current in ampere when the fan blades are intended to operate at a speed of 60 radian per second, that is omega. So we have to find peak to peak ripple value. So that is given as Vg minus Va, yes, divided by La. So here in this question we have to find Va, and already this Vg is given, that is the source voltage. So Vg is given as 100 volt. So we have to find Va, and La is also given, and after we get Vg Va, then we can find D, and Ts is already given. So Ts is equal to 1 by F, that is equal to 1 by 5 into 10 to the power of minus 3. So that is equal to 0.2 into 10 to the power of minus 3. So this is equal to 0.2 milliampere. So for finding Va, we know that this formula above we have seen IaRa plus Eb. So Eb is equal to Kw. So K is here given, that is 0.5. W is given as 60. So Ev will be 30 volt. And for finding IA, that is equal to TL by K. So TL is given as 0.002 into omega square, that is 60 into 60 divided by 0.5. So it will be 3072 by 5, that is equal to 14.4 ampere. So VA is equal to IA, that is IA plus EB. So this will be 14.4 into RA is given 0.5 plus EB is given 30 volts. So this will equal to 70, 72, 7.2 plus 30, that is equal to 37.2 volt. And also BG is given as 100 volts. So duty cycle, we know that that is equal to VA by VG. So that is equal to 0.372. So now we can substitute all this value. So this is equal to 100 minus 37.2 into 0.372. B is 0.372, and after that TS is, where is TS? And TS is 0.2 into 10 to the power minus 3. So we will get this answer in the ampere. So 100 minus 37.2. So this is equal to 4.67 milliampere. So we'll end up the lecture here only. From next week, I will ask all the TA to solve different questions. So that because my session comes at the end, so people can see the repetitive question in my session. So we'll try to take some questions from the outside the lecture series also, so that it will be helpful. And this video will be also uploaded on YouTube, so the students who have not watched can see, and the link will be shared in the NPTEL portal. Thank you everyone for watching the lecture. Today we'll close here.